Okay, example, find the 21st term of the arithmetic sequence when a1 equals 4 and d equals 3. So instead of writing out all 21 terms, we'll do this way easier. So if we want to know the 21st term, a21, that's going to equal the first term, which is a1, and we know a1 is equal to 4, plus n minus 1. So n in this case is 21. So 21 minus 1 times the common difference. So to get to the 21st term, we're going to take our first term 4 and add the common difference 20 times. Because that's what 21 minus 1 is, 20 times. So that's what this boils down to. So a21, or in other words, the 21st term is going to equal 4 plus 60. 20 times 3 is 60, plus 4 is 64. Okay, so this equation is essentially a shortcut. Find the 12th term of the sequence. So a12 equals a1, which is 6, plus n minus 1. This little number right here is n. So 12 minus 1 times the common difference. Now the common difference here is negative, so you just got to be careful. So 6 plus 11 times negative 5. So 6 plus negative 55 is negative 49. Which makes sense why you get a negative number, because you're subtracting 5 each time you go to the next term. So if you start with the number 6 and you subtract 5 11 more times, you're going to wind up with a negative number. Okay, these two you got to go a little backwards for. Now it asks you to find the first term, and you're given the last term. You're given a15. So usually we go like this. That's the equation we usually use. Here we know a15 is equal to 30. So basically we're going to plug the 30 in there. We don't know the a1. That's what we're trying to find. We're trying to find a1 here. So that will leave as a variable. N is going to be 15 minus 1, and d is 7. Now you got to solve this for a1. Makes sense? So this is just an algebraic equation to solve. 15 minus 1 is 14. 14 times 7. 14 times 7 is going to be 90. That's an A, by the way. 98. So 30 equals a1 plus 98. And then to solve for a1, you would subtract 98. Negative 68 is a1. Okay, so sometimes you might have to use that equation in other ways. You're not always looking for an. Sometimes you're solving for a1. Sometimes you're solving for n or d. As you'll see in the next slide. Look, this one wants us to solve for d. So that's okay. Just plug everything in. Plug everything in into the equation we know. So an is here. This is this right here. We know an is 42. a1 is 3. Now, what's our little subscript on that number? That's n right there. N is 15. We don't know d. So now we got to solve this. We would solve it by subtracting 3. So we get 39 equals 15 minus 1 is 14 times d. So 39 equals 14 times d. Divide by 14. This comes out to some weird fraction. 39 over 14. But that's the right way to do it. Alright. Last one. Find the term number n. So find an here. Or solve for n, I'm sorry. Here's our equation. It wants us to solve for n. So we're not going to know n. So we're going to plug everything else in. an equals 6, so the 6 goes here. a1 is negative 34, so the negative 34 goes here. We don't know n. We do know d. So to solve this, we're going to add 34, all right, to this side. get 40. So 40 equals n minus 1 times 4. And then to solve this, we would divide by 4 on both sides. So 10 equals n minus 1, and then add 1. So 11 equals n. That's how many terms there are in this sequence. If you wanted to, you could have also distributed this 4 and then solved it. Get the same answer. Alright. For homework, I want you to do this slide right here. Find the missing terms. Alright? Nice and easy.